My name is Jon Payne. I'm here to talk to you a little bit about some use cases that we have around scalability, particularly with regards to the new sharding capabilities that are in the InterSystems IRAs data platform. First of all, before I start, I'm aware it's a little bit, it's getting late in the afternoon. Quick show of hands. Who was in the previous presentation that was done by Harry and Jeff? So a couple of you, not everybody. Okay, so I'm going to start off the presentation, this session, with a brief introduction to the scalability characteristics of the platform for those people that haven't been in the last session, which covered it in more detail. This comparison, Harry's session was a lot of detail about how the SQL stuff works, a couple of use cases. This is a brief recap for those who weren't in that, followed by a number of detailed use cases, primarily on financial services, about sharding. So let's have a bit of context to this. So in terms of what's been happening in the financial marketplace, what's been triggering change? Well, there's really this drive for innovation and the move towards real-time information particularly. And that's primarily because of three reasons. I mean, the technology is enabling it now. Consumers are demanding it, they expect it. You expect to be able to get instant access to information about the things that you are doing, whether that's your bank account or whether that's your order status with Amazon or whatever. And particularly regulators these days are requiring information in real time in order for them to be able to manage the markets in a safe and transparent way. So four use cases that look at how these changes are impacting technology and how we provide it. So obviously IRAs, the InterSystems IRAs Platform, this new platform allows us to do things like ingesting big data rapidly, discovering information out of unstructured and structured data, running predictive analytics over the top of that data, and then being able to orchestrate action workflows based on the information that we discover in the predictive analytics, all in a single platform. So let's just do a quick recap on the SQL capabilities, as I say, for those that weren't in the previous session. So typically, or traditionally, the way in which we scale up the ability to process information has been vertical scalability. So you put in more CPUs, more cores. If it's a blades environment, you might be looking at 16 cores with two 8-core sockets at the bottom end, up to 96 cores with 4 24-core CPUs at the top end. After that, you go up to more exotic machinery where the cost goes up dramatically. It's not a linear increase. If you go to 16 or 24 socket machines, the price goes up not so much by factor, perhaps by more by an order of magnitude. And the software to manage and operate and use those machine resources is increasingly complex, becomes much more difficult to manage. In fact, what people end up usually doing is chopping them up into containers to have a small amount, and price performance really does suffer under those circumstances. So then, to take advantage of this multi-core environment, within our platform, we have the ability to parallelize queries, so we can take a query, chop it up, run each segments in parallel on separate cores. Each of those threads do work, return back the result, the aggregate gets produced and sent back to the consumer. So the current SQL compiler does that via %parallel. That's a compiler hint, and in the future, with InterSystems IRAs, that will become fully automated quite shortly. So then, okay, vertical scalability is expensive. Horizontal scalability, particularly with the pervasiveness of cloud-based computing, is obviously the way to go. So we instead of having larger machines, we have a larger number of smaller commodity pieces of hardware. Advantage here being obviously we've got pretty linear price performance. The cost is predictable. You just bolt on another blade. It allows you to elastically scale up and scale down if you're in a cloud environment. again, there is some software complexity here because here it's a networking problem. You're trying to partition workloads across multiple machines, across the network, bring the results back in a sensible form. So it's a different type of problem, but it is a problem. Now, in the InterSystems IRAs Platform, we've had some technology for a while that allows us to scale out the user-based workload. And this is really looking at the front end of an application. Most applications are resource intensive in those pieces of code which drive the user interface, which drive the business logic, and we scale that out within our platform using Enterprise Cache Protocol, ECP. And what this does is it allows us to distribute that application workload across multiple machines, and it allows you to horizontally scale the data cache that's serving that application workload because ECP maintains that cache transparently at the fringes. So that scales very well in that regard. However, it does reach a point where the data server at the back end that's supporting that ECP architecture starts to have too big a load. So what do you do when you do that, well, when you reach that point? Well, traditional solutions might have included artificially partitioning your data in some way, putting one table here on one server, one table on another server. It makes it more difficult to manage, makes it more difficult to orchestrate activity. So a better solution is to transparently balance that workload, again, across a series of servers in the back end. And this is what we're doing with sharding. So we're horizontally scaling the data and the workload that goes with processing that data across multiple back-end servers, and we're also scaling the cache cheaply and economically. So that's the amount of memory that we have available to store working sets in memory, so we don't have to go off to disk tiers to retrieve data so frequently, hence improving performance. And obviously this is all fully transparent to the application code in the same way that ECP is transparent to the application code. It's one of the key things about InterSystems IRAS. It's very simple to implement this type of architecture. There's very little work that's required from an application or even from a systems management perspective. So put the two together, we can scale the application workload, we can scale the data workload into a single cohesive network. Okay, let's move on to the use cases that I was alluding to earlier. And the first one that I'd like to talk to you about is FRTB, a fundamental review of the trading book. Now, this is a directive that's coming into force by 2020, and fundamentally what it's doing is it's moving the focus of risk calculations. And it's doing that for a number of reasons. If you look at the way in which risk in financial markets has been measured to date, generally it's been done from a regulatory perspective by using a measure called VAR, value at risk. The problem with the value at risk model is that it's got some flaws with it. Firstly, it didn't cover all the various different tradable instruments very well. Secondly, it assumed a normal distribution of events. So it assumes that the likelihood of an adverse event, a big market dislocation of some form, follows a normal distribution and a thin tail that's associated with the usual bell curve. Unfortunately, real markets don't work like that. They have fat tails. The adverse events occur more frequently. And in addition, VAR as a measure also assumes that if you have an adverse event, then you can still sell out the positions that are notionally not affected by that event. So if you have a political collapse in one major economy, it assumes that you'll be able to still trade your positions that might be in other currencies or other countries. Unfortunately, that's not really the way the financial markets work. They tend to be coupled. If one market goes down, then frankly, everybody tends to rush to cash and hang on to their cash and not want to buy positions. So suddenly, you're not able to trade out your other positions. So the impact of a severe market dislocation, history's shown us, it's more significant than value at risk would normally calculate. So The regulators have decided that conditional Var is a better measure. It's a reworked version of value at risk. It takes into account the fact that these adverse events happen more frequently. It needs to be applied across all the trading products, and it needs to be done on a more frequent basis. And this is the real killer if you're a trading organization, because typically if you look at the way a financial institution works, there's three main areas of operations: the front office, where the trading occurs; there's the back office, whereby all the processing and settlement occurs; and in the middle of the middle office is traditionally where all the risk management's happened. So in the middle office, they've been responsible for, they might be running VAR calculations, might be running the bank's internal risk calculations on an hourly basis. They'll be producing the risk reports at the end of the day. What FRTB is saying is that those risk calculations across a whole book now have to be done in the front office at the time you do the trade, so that the financial institution understands the impact of that trade before it actually makes it. That means that you're looking at somewhere between, it's been estimated, 30 to 300 times the amount of computations that are required within any sort of trading organization by the time it becomes compliant to FRTB, because they have to move these analytics from periodic in the middle office to at the time of the transaction in the front office. So the only way you can do this is automation is absolutely the key, because a lot of this middle office activity has been driven off spreadsheets and all that sort of stuff. That doesn't work anymore in the new world. So it's the sheer volume of data and the frequency which you have to process it in a real-time basis, which is a real killer for FRTB. These systems are absolutely mission critical. If you can't do the risk calculations, you're not going to be allowed to trade, frankly, which means that if you don't do those calculations, legally you're not allowed to trade. If you still trade, then you're open to, or the institution's open to very large fines from the regulator. So integration with existing risk systems is absolutely key. Lots of banks have invested lots of money in their proprietary risk management and tooling. They need to be able to continue to take advantage of that. But you need to be able to run these risk calculations in a cheap, affordable, effective manner. Otherwise, it just becomes ridiculously expensive to trade in some of the markets, certainly where there's not a lot of profit, the margins are thin, it's competitive, there's not a lot of activity. And indeed, we're starting to see some financial institutions already pulling out of a number of markets where they're just saying, well, there's no point because we're not making enough money to recover the increased cost. So what are the key capabilities of InterSystems IRAs that InterSystems IRAs brings that enables this movement of this risk calculation from a periodic basis to a near real-time basis? Well, first of all, if we're looking at the fact that this is all analytics, so we can take advantage of the capabilities of InterSystems IRAs to talk to Spark. So this is Apache Spark. You can build predictive models, your predictive analytics, proprietary analytics in a Spark infrastructure. We can cache all the data that reflect the bank's current positions, that reflect the market data, and that means that we have everything ready to press the button. We just change one position, away we go, just to do a quick recalculation, because we've got everything else set up within this large Spark infrastructure, which allows us to do these sorts of calculations in a real-time basis. Now, secondly, the fact that we have a very good integration into the Java world with InterSystems IRAs. So this is the ability to talk via shared memory between a Java JVM and the IRAs data platform, means that we can move data from the Java world into the InterSystems IRAs world very, very rapidly. We're not going around the TCP stack anymore to move data in or out. So that gives us two things. It gives us the ability to integrate with a lot of the analytical libraries that these institutions have already written. They've got reams and reams of proprietary analytics that are sitting in Java libraries today. But also, it means that we can very simply and rapidly ingest market data into the platform, because one of the main ingredients that we need to include in our analytics is current pricing. And if you've got major price feeds, you could be looking at, well, how many? 100,000, 200,000 price changes a second, ticks a second coming into your platform. And so you need to be able to not only read that data very rapidly, but you need to bring it into your appropriate structures where you can apply the risk calculations. So if we look at how that maps out logically into the various different components that an InterSystems IRAs architecture might include, we start off with the data master in the middle. That's talking to a number of data shards. We're caching data in some query shards so that whilst we're loading data in real time into the data shards, we're also not blowing away our query cache, so we're maintaining as much data in cache, in memory as we can. We've got strong integration with Spark, where we might be running predictive analytics, we might be running R, we might be running a whole bunch of stuff. We've also got integration with the proprietary Java libraries, where we're running some other in-house calculations and where we're loading data from. So this gives us an architecture where we can do that sort of analytics in very near real time, at the same time as ingesting lots of data which then don't impact the performance of our analytics. And that's a very key capability. Okay, I think I've talked enough about that one. Let's move on. MiFID II, Marketing Financial Instruments Directive. This was due to come into force about 2 years ago. Institutions have had difficulty complying with it. It's now finally coming into force next January. And what's this all about? Well, it's all about transparency. MiFID II is all about ensuring that it becomes very clear when a trade is done, who that trade is done on behalf of, who's affected by it, who's the counterparties by it, what commissions and charges are associated with that trade, and reporting that information to the exchange on which that trade is done in near real time. So again, traditionally or prior to MiFID II and MiFID I, that reporting was done on an end-of-day basis. So the asset managers sort of might have done that as a batch process, run off a report, send it off to the exchange. That's fine. Now, with MiFID II, they have to do that reporting within a minute. And you think, okay, well, within a minute, you can actually do a lot of processing within a minute. However, it becomes a little clearer the scale of the problem when you look at this graphic. I picked this up, well, actually it came via, I saw it first via LinkedIn from a company called Icestorm. It just illustrates the operational areas where MiFID II is having an impact on institutions, particularly that are trading on behalf of private investors, which is where MiFID really has an impact. And it covers pretty much all the full gamut of operational behavior within an institution, as well as impacting their financial performance, because they have to not only be transparent about the financial impact of transactions, but also they have to be transparent about the costs that they're incurring. So, the real issue associated with doing this reporting in near real time is, well, if you look at it, take an example of a major asset management company. Some of the big asset managers, certainly in London, they might be looking after 20,000 funds. Well, where for example, if you're managing a pension, you might invest in 10 or 20 or 50 funds. A major asset manager might be running 20,000 funds. They might be managing portfolios for high net worth individuals, and it might have 50, 100,000 high net worth individuals whose portfolios they're managing. They might be managing a larger number of portfolios on behalf of other financial institutions if you're one of the big asset managers. So they have a big network, not only of funds that they're looking after, but also the beneficiaries of those funds, the individuals who have bought into those funds. And so if that institution does a trade, it buys you know, 500,000 shares, or I might buy 2 million shares or 10 million shares in Amazon or something like that, to partition those out across those funds, the institution then has to work out not only which funds are going to be affected by that trade, you know, where that trade is going to be allocated, but it also has to know which individuals holds those funds, or which portfolios are going to receive those shares into, and therefore the full network of institutions and individuals that are going to be affected by this trade. Because every single person, every single institution, every single fund has to be reported to the stock exchange, in this case, you know, the exchange in which the trade was executed, in less than a minute. And suddenly you've gone from a situation where we can just run a report at the end of the day and doesn't really care how long that takes, to we've got this vast amount of reference data, we've got this vast structure of customers and in relationships between those customers and funds that we have to, you know, build a tree of relationships from, bundle that tree up and report it very rapidly. So that becomes a major problem to solve. So the way that we support that within IRAS, we have this very rich capability where we hold all these complex web of reference data of relationships between customers and funds and where a trade is going to be allocated, hold that in query cache because we need to very rapidly be able to analyze this tree to be able to report on it. And then we can use the communication capabilities, integration capabilities that are built within the platform to report the result of analyzing that data set. So if we look at the architecture associated with here, we've got a sharded database. On top of that, we've got a number of ECP application servers, and those are basically holding the data in cache to support the network query, the network analysis that's required. And then once we've done that analysis, the core platform that is going to send this information off to the exchange. Okay, so let's move on. I thought at this point I'd throw in a use case that wasn't financial services, just to give you a bit of a break, before I come on to the final one, which is probably the largest use case. And this is an example that's taken from a customer that we have in the Far East, and they're doing some work in the area that's historically been described as the Internet of Things. So this is all about having lots of sensors collecting data in real time, being able to capture, process, analyze that data, draw information from this. So in this case, it's an industrial automation example. They're actually in the car manufacturing business, and they've got over 1,000 major devices. And by devices, it's things like robots or manufacturing machines that they're collecting data from. And the data they're collecting, well, the machines are continually measuring information, and then every 30 seconds they send a burst of data back to the server. And that means that from these 1,000+ devices, these 1,000+ robots, whatever, we're getting about 2 megabytes per minute per device. That equates to about getting on for nearly 3 terabytes a day, or about a petabyte a year, if my maths is correct. And they want to keep that for about 10 years. So that's about 10 petabytes of data. So that's a large amount of data. It's pretty fast moving. It's continuous stream because they're a 24/7 operation. And what they want to do is they want to analyze this data in near real time because they want to run predictive analytics across it because they want to detect those tiny variances in performance which give a hint that a machine is likely to fail at some point in the future. And you can do that by seeing differences in the amount of electric current the machine might be drawing, or the slight variations in time that it takes to complete a particular operation. And that gives you once these fall outside certain statistical bounds, it gives you a hint that the performance of the machine is varying, and that means there's likely to be a problem with it. So they want to be able to identify where these problems occur and go and do preventive maintenance So that means they then have less interruptions to production, and therefore they're more profitable. It's ultimately the driver for this. So we need to store this data in an organized form subject for immediate analysis. It comes in quickly. And we have to be able to ingest this data faster than the data arrives. And that seems like an obvious statement, but it's not necessarily that simple to do. I mean, again, if you look at what happens traditionally in a lot of the big data warehousing, data analysis type environments, organizations, particularly that want to persist large amounts of data, tend to bring it in, store it in some sort of unstructured form, and then later on unwrap it, unpack it, structure it, and then do an analysis. In this case, what we want to do is we want to store that in a form that's immediately available to be analyzed. And then we want to iterate over this in many different ways in parallel to carry out predictive modeling. Predictive modeling is basically a core tool of that. It's what's called the Monte Carlo analysis. So that is, you set up a scenario, do an analysis, perturb a data item a little bit, and do the analysis again. So you might do 1,000 runs to come up with a decent stochastic analysis. And you want to repeat that activity very frequently, because what you want to do is detect those minor changes in behavior before something goes wrong. So really here, the capabilities that we're looking at, rapid data ingestion, again going back to this shared memory capability to talk into the platform, bring data in very rapidly, and highly scalable data storage, massively scalable data storage, being able to maintain that data in a structured form that can be analyzed and iterated over. So here we're looking at data master, series of data shards, queries, and loading going on in parallel. We're not, in this case, particularly worried about caching lots of data, because the predictive analytics aren't that time critical, but we certainly want to store it in an efficient manner, and we want to be able to analyze it in a way that doesn't necessarily get directly impacted by our load. So here we're looking at the ability to load data directly into the shards, so we don't have to go through the master all the time. Particularly if we're looking at time series data, a simple layout for this might be you might have a shard per year. And you're always loading data into the current shard, but the other shards are there for historic analysis capabilities. You might look at something more granular than that. So there's lots of strategies for being able to load the data in on this sort of scale and manage it on this sort of scale. Okay, so let's move on a little bit more into our final use case. So I just need to take a quick drink of water. So this is Payment Services Directive. This is another piece of legislation that's been introduced by the EU, and organisations have to be compliant with this by 2019. And if you remember when I started out, I talked a little bit about innovation. And Payment Services Directive is really all about capturing that innovation, being able to roll that innovation out into the financial services market in a way which preserves the interests of the consumer. So it's a way of being able to encourage change in the financial services arena, but at the same time do that in a way that protects the citizens, protects the money that the citizens have, protects their rights, protects their interests. And it also is a way to deregulate the market, because if you look at the way the financial services market works, there tends to be a number of big players who are incumbent, they hold relationships, and there's big barriers to entry from new companies who want to offer niche or innovative services, primarily because of the regulatory compliance burden. So PSD2 is a way to look at addressing that. It's all about helping new suppliers enter the market, protecting customers, and reducing the entry costs, thereby supporting innovation in the market. In order to comply, the banks have to do a number of things. They have to provide a new set of APIs because they have to be able to serve data out to third parties on demand. They've been told that they have no choice. And to support that, they have to integrate their data from their in-house systems in ways which hitherto they're not necessarily been doing. So that gives a bit of a problem. So if we look at this graphically, PSD2 really covers two areas. On the right is an account information service provider. So this is a third party who's come into the market and says, Paul, I'm going to give you a new view of your financial information collected from 4 different banks, an investment house, where you have accounts, where you have a mortgage, where you have credit cards. I'm going to pull that information together and present it to you in an innovative way and perhaps offer some services around that your existing financial institutions don't offer. In order to support that, the banks have to provide APIs. PSD2 mandates the provision of those APIs and mandates that the banks have to provide access to those APIs. Obviously, it's predicated on Paul giving permission for that to happen. However, what it means is that Paul will be able to get a new type of service from these account service providers. The second arm of PSD2 is the payment services providers. So these are new payment service intermediaries who are cropping up. So if you look at historically, you, the customer, would have taken your credit card into a merchant, bought some apples, well, maybe not apples, but a big bag of apples if you're paying with a credit card. The merchant would run your credit card through a machine that would talk to a credit card processor, and the credit card processor would talk to the card network, and that would eventually go back to your card issuing bank. What the payment services processor will do is they'll talk directly to an API, via an API to your issuing bank and cut out the card networks. So this is disintermediation. This is what the dot-com boom was all about. And it's a classic example of disintermediation. So the people like American Express and Visa and MasterCard have got potentially problems here. So you have suppliers that could be Apple, for example, with Apple Pay. Instead of you registering your credit card with Apple Pay, you could register your bank account with Apple Pay. And then there would be no need for a credit card provider in between. Again, the payment services provider talks to the issuing bank via an API that the issuing bank has to provide by law. So that's what PSD2 is enforcing. Obviously, there's a bit of arguments between the banks and the regulators as to the nature of those APIs, because the people who are setting up the account service providers or the payment service providers would like, a neutral API that is the same for everybody, and all the banks want to have their own version. So a bit of an argument going on about that at the moment. But still, I think hopefully you get the idea of what's going on here. So the banking sector has to make substantial changes to their technology in order to do this. First of all, there's still an enormous amount of legacy application within financial institutions. And by legacy application, I'm talking about back-end processing systems that might be 30 years old or more, that are still running. Now, a lot of these are so old that they're just unable to provide real-time information, and certainly not to be able to surface it through any sort of usable API. In addition to the problem of getting hold of the information in the first place, the banks then have to surface that and manage an increasing number of requests for that data coming in. So not only are they going to have to process the transactions on their own internal systems, but they're going to have an increasing volume of requests for tell me everything you have about Paul, coming in from the various different providers. So that means that, again, it's an order of magnitude increase in the demands on the systems that the banks have for information. In order to service this, their systems have to be robust, they have to be scalable, they have to be low cost, and they have to have integration capabilities across all these different types of technology. In fact, it's so hard, a number of banks are saying, actually, we can't do it with our existing systems. And some of the, Deutsche Bank have a budget for 2018 in excess of, well, it's about €1 billion to create new systems. BNP Paribas have said, in effect, they're setting up a new digital bank within the bank because they recognize that meeting PSD2 with their existing systems is so hard, they're not even going to try. So this is a bit of a step change for financial institutions, and this is having a really big impact. So if we look at, again, the capabilities that InterSystems Iris brings into this new world that really is revolutionizing the way the banks are looking at how they handle and process data. Orchestration of back-end legacy applications. So this is the integration capabilities within the platform, the ability to orchestrate activity across different connected systems. For those banks that have applications that can surface the data, then we need to be able to orchestrate the activity across those. We need to be able to get it. Multi-model operational data management and coupled with new applications. Well, this is alluding to the fact that particularly if you're creating new applications rapidly, deploying them rapidly, just using a data source that provides SQL access to data is not the way to do things anymore. You need to be looking at models which encompass data persistence, handling document views of the world with JSON and REST to integrate into different types of front-end, different types of API. There's a whole new world of different ways of viewing and manipulating data that InterSystems Iris supports. That enables you to build out new operational systems and solutions very rapidly. We need to be able to do the analytics on all the data that's being held in here. So we've got structured data, we've got lots of unstructured data flying around. There's still an enormous amount of paper in the banking industry, in the financial services industry, and the content of that paper is still very important. If you're for example, if you're processing an application for a mortgage, God help us, that's still a massively paper-based process, even though a document-based process, even though a lot of it's been offloaded onto websites these days. There's still a lot of documents moving around. And we need to be able to handle that unstructured information as well as structured data. And we've got to be able to do it cost effectively. We can't go and build out new applications and take 10 years to do it with a team of 500 people. We've got to be able to do them. We've got to be able to build these out rapidly, small lean teams, deploy in a cost-effective manner, and work in a continuous way. Because one of the impacts of PSD2 on opening up the market to innovation is that if the financial institutions are going to survive, they're going to have to innovate constantly, because that's what the market is doing around them. And if they don't innovate at the same rate, then they will increasingly be left behind. So, you want to be able to tie into continuous development, DevOps way of working, all that sort of thing. So if we start to look at, again, the sort of architecture you might end up with, well, we have ECP application servers serving out the APIs, supporting the creation of data in new applications, handling the integration where we're still talking to existing applications and then banks where they're capable of doing that, coming into a data master, talking to the various data shards. We've got query shards there because what we want to do is we need to be able to support the querying of the data, surfacing it through out to the new intermediaries without impacting our operational flow. So we've got a fairly mixed bag of all the various different capabilities of the IRAs platform coming together to support the requirements of PSD2 and indeed other similar regulations happening elsewhere. Okay, so if we want to look at a summary of what we've talked about, we're looking at structured and unstructured analytics, multi-model operational data management, orchestration and integration, the ability to rapidly ingest data in parallel, highly scalable tiering out at the data layer and at the application layer, integration into external analytics such as Spark, particularly, low-cost DevOps way of working, high-performance JDBC, integration between capabilities in the database, in the data platform capabilities, in the market feed sources of information, all of that coming together in our platform supports these types of initiative that's going on at the moment. This change in regulation, this move to a world where data is moving around more quickly, it's presented more quickly, it's reported on more quickly. So, summing that up in one picture, it's all about a panoramic view of dissimilar data sets, whether it's structured data in SQL tables, whether it's documents, whether it's an analytical model, scaling horizontally and vertically. Multi-workload is a key thing to remember. Mixing a transactional workload and an analytical workload on one platform without the need to take your data out of your operational systems and put it into a separate analytical platform. We can do this all within InterSystems Iris. Okay, I think I'm just about to run out of time, so I'll stop there. Any questions?
A big question arises with all these different directives.
Mm-hmm.
Some of them you specifically said are EU directives. Will some of these be lost depending on the Brexit negotiations inside the UK or delayed?
So the question is the impact of these directives going to be diluted or removed when the UK leaves the EU as a result of Brexit? The answer is no, because the UK has already indicated that it will conform to all of these regulations. I'm aware that in the US there's a certain liberalisation at the moment in terms of financial services regulation that's going on. However, I think in the long term, these sorts of things are going to become more impactful in the US as well. They certainly are in the rest of the world. It's all about transparency, it's all about speed of reporting, it's all about managing risk in a more appropriate and timely manner. And those are imperatives that apply the world over. Does that answer the question? Okay. Anything else from anybody? It's the end of the day. Oh, sorry.
So, like the last slide you had where you said, like, having transactions and analytics off the same server.
Mm-hmm.
Because historically it seems like, having analytics off of like a mirrored server, not the transaction server, has been like the best practice.
Right. Well, when I say the same platform. So if you look at the architecture, we've got, for example, data shards and query shards, and those are probably, those are probably going to be running in separate VMs, but they're all part of the InterSystems Iris platform. They're just different components of that platform, and we configure those components based on the nature of the workload that we want to put through. Depending on the use cases that you want to match. And we've seen some examples of those different configuration options, how they might apply. Okay. All right, anything else? In that case, thank you very much for listening. At the end of the day, appreciate it.